All right. Page 434, number 19. We got sine A plus cosine A, that quantity squared, is equal to 2 plus secant A cosecant A all over secant A cosecant A. Alright. Okay, this one probably, well, it definitely is tougher than the ones I'm seeing on the quiz tomorrow, but that's okay. It's good to do these and make the ones a little bit easier tomorrow. The reason this one's a little tricky is because if I were doing this one, I'd even probably have to mess with both sides a little bit to see that they are the same, and then erase the work on one of the sides, just because you wouldn't see it, I don't think, right away. The side that I would definitely work with would be the right side in this case, okay? Because if I can change all those to sines and cosines, I can make it look like the left side. That would be my approach. So 2 plus. Now I'm going to change those to fractions, all right? Cosine A, sine A. Everybody see what I did there? And then the bottom would be the same, right? 1 over cosine A, sine A. So that would be kind of my first approach, is to change all those to terms of sines and cosines. Because hopefully I can simplify it to make it look like the left side eventually. What might we do next? Multiply by the reciprocal. You certainly could at this point. Some people may have added these two terms together here first. Totally fine too. I probably might have done that myself even. That's the first thing I heard, so I will do it that way. Okay? But some people might have added these two together by making it have a common denominator. So you'd have to multiply the 2 by cosine A sine A over cosine A sine A. So you have a common denominator, so you could add them together. Okay? But if I just take that whole entire numerator and multiply it by the reciprocal right now at that moment, that'd be okay too. Okay? So I have the numerator, I got the top, the numerator, divided by a fraction. Well, what you can do is you can multiply by that fraction's reciprocal. So cosine A sine A over 1. Now the thing is that you do have to be careful about is in your numerator you had two terms. You had 2 plus a fraction. So if you're taking that whole numerator times this fraction over here, you got to make sure you do what with this fraction? Distribute it. Okay? So 2 times this fraction would be what? 2 cosine A sine A. And then this fraction times cosine A sine A would just be what?
1.
1. Okay? Because they cancel out. So we've done a pretty good job. We've taken kind of an ugly fraction with secants and cosecants, and we've gotten it to sines and cosines, but it's still not really looking a lot like that left side. This is where I would probably have to mess a little bit with that left side to realize how they're the same. Okay? If I square this, that means I'm taking this times itself, so I'd have to FOIL it, right? When I FOIL this, you'd be taking sine times sine, which would be sine squared. Then you'd be taking sine times cosine, and then another cosine times sine, and what do you get?
2 cosine sine.
2, I'm going to go sine first, sine A, cosine A, but it doesn't matter. And then you'd also have cosine squared A, right? Say something if you want me to write out the FOIL. Everybody good on me foiling? Drew?
I was just going to go to the next thing. So wouldn't sine squared A plus cosine squared A just be?
Yep. Drew's noticing this is really 1, isn't it? And these two things add together. If they're 1, don't we have exactly that? So knowing that, the way I would go about doing this is I might actually, what it'll look like you working backwards, I might replace the 1 with what?
Sine squared.
Sine squared plus cosine squared. So 2 cosine A sine A plus sine squared A plus cosine squared A. Not sure what's going on there. And then we know that this, because we kind of did the work up here, right? We know that what we have right now here is exactly the same as this. So you could go ahead and write sine A plus cosine A squared. And then what I'd just go back and do is I would erase that part. So sometimes it helps to work with both sides to see how they become equal to each other. But in the end, please erase all your work on that one side and just make sure you're showing your steps on how you could get to there. Derek?
So we couldn't mess with both sides when we did like the same answer?
Correct. Nope. To do a true proof or verification, you're trying to verify how one side is equivalent to the other side. Don't work with this one side. Show how this side we can make it equal exactly.
It doesn't matter like what side you mess with. Like,
Correct. It would not. No. I think it would have been difficult for you to go from this to this. I think that would have been tough.
How'd you do that? Would you FOIL and what?
Well, you'd have to be changing all your sines and cosines to cosecants and secants.
Would you do that off the bat and then FOIL? Or?
Probably. And then you'd have to maybe make a common denominator with all those fractions that you'd have.
Yeah.
I think that's probably the approach you'd have to take. I'm not saying it could or couldn't be done. I haven't tried it, but so. Again, I know I probably won't put one that difficult potentially on a quiz, but I think it's good to see different ways to do different problems. So that's why I kind of like that one. What questions do you guys have on this one? Speak up if you have them, Tyler.
Can we go over the way if we have to take like the top of it and have common denominator? Like if we have.
If I wanted to add those together, okay. If I wanted to add 2 plus 1 over sine A cosine A, if I just wanted to add those together, this 2 is over a 1 in a sense, right? So in order to add these two fractions together, I need a common denominator. Well, this would be my common denominator, so I have to take the top and the bottom of this fraction times sine A cosine A. So I take this times sine A cosine A, and the bottom times sine A cosine A. And you have 2 sine A cosine A plus 1 all over your common denominator. Does that make sense?
Yeah.
So you got the same thing. You got the same thing in here, okay? When you would add those together, but then, so when you add them together, you get this, but then you would have to take this and multiply it by the reciprocal of the bottom, and that's where this would then cancel out, and you'd just be left with that top. Did you follow me there?
Yeah.
Okay, I was doing some wrong screens there, so I apologize, but when you do the top, you still need to take that top and multiply it by the reciprocal of the bottom. So you'd have to do this to our answer. And if you take this times this, that cosine A sine A cancels this cosine A sine A, and that gives you just your 2 sine A cosine A plus 1. Make sense?
Yeah.
Okay? Anybody else questions on that? Okay, got another one? 6. Okay? Yeah, I'll do it here a second. All right. A lot of working backwards. It is difficult. Yeah, these are problems I just can't make up off the top of my head. Yeah, I take them from the book if I ever give you extra practice stuff. Or I find ones in the book, or I find ones on a worksheet, or I find ones.
How do you do it for the test? Do you make them your own, or just
No, I find some that either you.
not done?
There might be one you've done before. If you've done them.
Probably not done.
No. Just saying. So I'm not seeing this one right now. Just I can't look at it and know exactly how I'm going to do it. There's comes problems like that where I just can't. I can usually go a few steps ahead in my head, but I can't get myself to where we need to go. So, what do you think an approach might be?
I choose left.
Work with the left side, same thing.
Change secant.
Change secant and tangent to sines and cosines.
Oh, I thought you just divide the right side by cosine.
Divide the right side by. What do you mean?
Can you just take it all divided by cosine? Oh no, am I right?
Well, we're just if you're working with this side, you can do stuff to the top and the bottom of the fraction, but we're not going to divide both sides of the equal sign by cosine, or what did you mean?
Just divide the right fraction by cosine. You get rid of cosine.
So
on
take
top.
it times 1 over cosine on top, and take it times 1 over cosine on the bottom?
Yeah, I see that.
So then you'd have tangent and 1 over cosine. Just
Oh, yeah.
Oh, nice. Yeah,
makes sense.
I like it.
You got lucky.
I was not going that way at all. Right? That's pretty good.
The other way, I would not think
Yeah,
of
I
that.
wouldn't have taken that.
Yeah,
So
no,
the other
I
way,
didn't
I
think of
wouldn't
it.
think of
So that's really good. He would multiply the top and the bottom of the fraction here by 1 over cosine x. When you multiply this by 1 over cosine x, what do you get? 1. When you multiply this by 1 over cosine x, what do you get?
Tangent.
Because you get sine x over cosine x, which would be tangent x. And then you take this times 1 over cosine x, and you get secant x. So that's pretty good. Okay. So that would be definitely a very simple way to do it, but a lot of you have said you wouldn't have seen that. So, what is another way? Like change tangents and secants to sines and cosines? Would everybody have probably that didn't see what Dakota did probably have tried that?
Yeah.
Okay.
I would definitely say just
So I get sine x over cosine x plus 1 over cosine x, right? Equals that. What's the nice thing about those two fractions?
They both have had numbers.
They have a common denominator, so could I write it as one fraction?
Yeah.
Yep. So 1 over, what would that fraction be?
Sine x is cosine.
Maybe sine x.
sine x plus 1 all over cosine x.
And you just
Then
multiply
I
by
multiply by cosine.
And then now you have 1 divided by a fraction. So really you just take 1 and multiply by that fraction's reciprocal, and what do you get? Exactly what we want, right? If I multiply 1 by the reciprocal, I'll get cosine x over sine x plus 1. And that equals cosine x over sine x plus 1. Okay? So, definitely something that you guys could have gotten doing it that way as well. Okay? Any others?
Can we do 7?
7? Alright, I worked this one out this morning, and the student that was attempting this one changed these to sines and cosines and made it become a single fraction, but we weren't really getting anything close to that. We were kind of coming to a stopping point. We maybe could have tried a trick like multiplying by a conjugate or things like that to try and get it to cosecants and cotangents over there, but it really didn't work out very well. Then we tried working with this side by changing it to sines and cosines and make it look like this. But again, we simplified it nicely, but it really wasn't close to what this was. Okay?
Could you change them both to sines and cosines and then simplify both? And
Change them both to sines and cosines, simplify them both, and maybe work backwards, potentially. Potentially you could do that. Because we could see how they could equal the same, and maybe you could then work backwards on one to get it to equal. So that's definitely a possibility. Because both sides have cosecants and cotangents, if you look at this here and this here, they are what? Not opposites, conjugates. And remember how I've said before, sometimes it can be helpful to multiply by conjugates. It might simplify nicely. Do you see then how maybe multiplying the top and the bottom of this fraction by this conjugate might help us, because it would get that somewhere in our answer then? So if I take both the top and the bottom by cosecant theta minus cotangent theta, cosecant theta minus cotangent theta. If I multiply the top and the bottom, one times that is, that's nice, cosecant theta minus cotangent theta. On the bottom though, what am I going to have to do? You have to FOIL it out, because you have a binomial, you got two terms times another two terms. So cosecant times cosecant, cosecant squared. And now watch this here, cosecant times negative cotangent, but then positive cotangent times positive cosecant. What do those two products do?
Cancel each other out.
Cancel each other out. And then last I'll have minus cotangent squared. So, I'm close. I got the numerator right, but the denominator is not what I wanted. Thoughts?
Wait. Does that simplify to 1?
Does that simplify to a 1? Could that maybe be some sort of Pythagorean identity?
It is because.
Yeah, because cosine.
We know that sine squared plus cosine squared equals 1, right?
I would equal 1.
And if we divide everything by sine squared, we divide that by sine squared, we get 1. Divide that by sine squared, you get cotangent squared. Divide that by sine squared, you get cosecant squared. If I subtract cotangent squared from both sides, wouldn't it be true that cosecant squared minus cotangent squared then is equal to 1? So, yep, very good. Way to notice that, Pythagorean identity there. So really, this is just 1 right here. So you're left with simply cosecant minus cotangent. Anytime you see things that have squares in them, there's a good chance there might be some sort of Pythagorean identity that's going on there. So I'd always kind of look for that. It might be very helpful to write down all 3 Pythagorean identities kind of at the top of your page on the identity side tomorrow. That way you can kind of refer back to it if you need it.
So, they can like flip too. I didn't know that before the test. Like, they can actually like.
Yeah, you can manipulate them a little bit and yes, correct.
Were you gonna work on these story problems?
Yep. All right. Any other questions right now on identities?